Hello students, welcome back to the another chapter of solving previous year Neet numericals. Today we are going to discuss about the chapter current electricity. So without any delay, let's get started. So the very first question is based on electric current. A flow of 10 power 7 electrons per second in a conducting wire constitutes of a current. Okay. In the question they have given number of electrons per second, that means n by t is given. The very first question solution. Observe guys. So general formula for current I is equal to Q by T. According to quantization of charge, Q is replaced with Ne divided by T. So they gave number of electrons per second, that means n by T value is given, which is equal to 10 power 7 into charge of an electron is 1.6 into 10 power minus 19 coulombs. So final answer I is equal to 1.6 into 10 power minus 12. Which option matches? Option A is the correct answer. Got it? Ampere. So let's solve next question. Next questions are based on Ohm's law. So before going to the Ohm's law, I would like to give a basic note. So actual formula of Ohm's law is J is equal to sigma E. J is equal to sigma E, where sigma is conductivity, E is electric field, J is current density, which is a vector quantity. Electric field is also a vector quantity. Let me write down that. Check out the variables. So J is current density, sigma is conductivity. Generally sigma can be replaced as 1 by rho, where rho is resistivity. So rho is resistivity. Okay. Conductivity and resistivity are the properties of the materials, and E bar is equal to electric field. This is the actual formula of Ohm's law. So let me consider one conductor of length L and area of cross section A. Length is L, area of cross section of this conductor is A. I am going to apply some potential to this so that charges will displaces. The potential difference that I am giving is V plus minus. Here it is plus minus, and electric field direction is always from positive charge to negative charge. Relation between electric field and potential is V is equal to E into L, and E is equal to V by L. We can replace it, and J is replaced with I by A. Let me substitute these two values over there. Then J can be replaced as I by A, which is equal to sigma into E can be replaced as V by L. So from this, let me write down relation V. V is equal to sigma can be replaced as 1 by rho, right? So 1 by rho L. Then V is equal to rho L by A into I. This is the formula we used to use in numericals. So whenever Ohm's law concept comes, this is the formula we are going directly. So here rho L by A is replaced with a resistor. Resistance of the wire. Resistance is equal to rho L by A. Here resistivity is replaced as M by N E square tau. Where tau is time constant, M is mass of that electron which is displacing, N is number of electrons per unit volume, and E square is E is the charge of that electron. So this is the way to replace a resistivity. Resistivity is a property of material. It does not depend on L, A and resistance values. It does not depend on V and I values. Okay, it depends only on the material. Okay, these are the basic formulas based on Ohm's law. Let's solve numericals. The resistance of a wire is capital R. If it is melted and stretched to n times its original length, the new resistance of the wire is. So generally whenever there is if a wire is stretched or compressed by n times, the formula for a new resistance of that wire is R new is equal to n square times of r old previous value. So how this is n square times of previous value? Let's imagine a wire of length L and area of cross section A, which is having a resistivity of the material is rho, and resistance of this wire is R is equal to rho L by A. Now I am going to stretch it. If I stretch it, its length, let's say I am stretching it by n times. Now its length became n times. It is going to be total n times of L. This is the final length. Then what happens to its area of cross section? See, because as wire is same, if I stretch this, volume of the wire remains constant, right? Then area will be decreases by n times. How can you say this? Volume of the wire is generally constant, right? Volume and length relation, volume is directly proportional to say volume is directly proportional to area and directly proportional to length, which is constant. So I can decide like this: area of cross section is inversely proportional to length. If length increases by n times, area of cross section decreases by n times. So from this, resistivity of the material doesn't change if I increase or decrease the length of the wire. Then new resistance is equal to rho L2 L final divided by A2. So rho L2 is L final, which is equal to how many times of L? N times of L. A2 is A by A, it is reduces by n times, which is equal to n square times of rho L by A. So where rho L by A is the old resistance, then new value of resistance R new is equal to n square times of R old. So this is how we are going to get a new resistance. Let's solve the numerical. Which option matches here? For question number 2, option B is the correct answer. Okay, so let's move on to the third question. A wire of resistance 4 ohm is stretched twice its original length. The resistance of a stretched wire is, again same procedure. Third one. So as R2 is equal to n square times of R1. So what's the value of R1? R1 is 4. N, how many times I'm stretching? Sorry, its length became twice the original length, right? That means n is equal to 2. So 2 square into 4, which is equal to 16 ohm. Which option? Option B is the correct answer. Okay, let's move on to the next. So question number 4. So what is the question they're asking? A wire of certain material is stretched by 10%. Okay, stretched by 10% in the sense its length increases by 10%. Imagine original length is L1. Now it is stretched by 10%. That means original length is L1 and this L1 is stretched by 10%. That is 10 by 100 times of L1, which can be replaced as 1 by 10 is 0.1, 1.1 times of L1. So L2 is equal to how many times? 1.1 times of L1. Here 1.1 times of L1 is replaced. This value is equal to n. How many times that I am stretching? Okay, so what is the question they're asking? The new resistance and specific resistance becomes, so resistance R2 is equal to n square times of R1, which is n square in the sense 1.1 square R1, which is equal to 1.21 times of R1. So R2 is equal to 1.21 times of R1. That is option D matches. What about resistivity? I told you already, resistivity is a property of material. Property of material. It doesn't change if length or area of cross section changes. It changes if temperature or some other parameters changes. So we know the relation of resistivity, right? Here I wrote it depends on mass, n, charge and time, relaxation time. Based on those properties only resistivity of the material changes. Okay, so for the given question, which option matches? Option D is the correct answer. Okay, let's move on to the next question. Question number 5 answer. So the electric resistance of a certain wire of iron is R if length and radius are both doubled. Length and radius both are doubled. R is directly proportional to length, inversely proportional to area. Area is directly proportional to pi r square. So I can write down it is as inversely proportional to r square. because A is equal to pi r square, right? I'm just writing proportionality, so I can remove pi value. So length doubled and the radius is also doubled, then R2 by R1 is equal to L2 by L1 into R1 by R2 whole square, where L2 is equal to 2 times of L1 divided by L1, then R1 by R2 is 2 times of R1 whole square. R1 will get cancelled, L1 will get cancelled, 2 1 square will get cancelled, you are going to get 1 by 2. Then R2 will become 1 by 2 times of R1. Which option matches? The resistance will be doubled, the resistance will be halved, and specific resistance remain unchanged. Just now we spoke about specific resistance is a property of material which does not change. Next, question number 6. Okay. A 6 volt battery is connected to the terminals of 3 meter long wire of uniform thickness and resistance of 100 ohm. Okay, so observe this. A wire of length 3 meter, so I can write down it is as 300 centimeter, because next case they are asking in 50 centimeter only. Okay, so uniform thickness and resistance of this wire is 100 ohm. Okay, the difference of potential between 2 points on the wire separated by a distance of 50 centimeter. Okay, so for 300 centimeter, what is the potential? 6 volt. Now what should I have to find out? For 50 centimeter, what is going to be the potential? I have a trick for this. You can directly apply this. That is, for 300 centimeter length, if potential is 6 volt, then for 50 centimeter length, what's going to be new potential? So let me write it down. So V2 is equal to, so this value, that is 50 divided by 300 into 6. So 6 5s, which is equal to 1 volt. So this is the correct answer. This is the way to answer. So it's just a shortcut way. Whenever there is a proportionality, you can directly answer like this. So you remember this method. I'll repeat that. So the trick is, if A is B, then what is C? So it's a direct proportionality. To find out this direct proportionality, then D is equal to C by A into B. This is the formula I am going to use. If you have any doubt, let me give an example. For 10 rupees, if I am getting 1 apple, for 20 rupees, how many apples I am going to get? So the method is x is equal to 20 divided by 10 into 1. So 10 will get cancelled. So x is equal to 2. So is the answer that I am getting is correct? Yes, it is. That's the approach. Based on that approach only, yes, I did solve this question. Okay, let's move on to the next. So 3 copper wires, 7th question. 3 copper wires of length and cross-sectional area are given. Resistance is minimum in which case? Okay. Formula for resistance, question number 7. Resistance formula, R is equal to rho L by A. So let me check it out. So first case is R1 is equal to rho L by A, R2 is equal to rho into 2L by A by 2. So it's going to be A by 2, which is equal to 4 times of rho L by A. So which is 4 times of R1. Next, R3 is equal to rho L is L by 2, A is 2A, which is equal to rho L by 4A. Rho L by A is replaced with R1 by 4. So question they're asking, resistance is minimum in which case? I think in the last case. So if area of cross section is, check out that. So area of cross sectional 2A, there is going to be area is, resistance is minimum, that is R1 by 4 times. So here it is. Hope you understood. Okay, so let's move on to the next. Question number 8. A wire of length 50 centimeter long and 1 millimeter square in cross section carries a current of 4 ampere when connected to 2 volt battery. The resistivity of the wire. Okay. Question number 8. Let's use Ohm's law. With the help of Ohm's law, we can answer this question. That is V is equal to I into R, where R is rho L by A. Rho L by A. So we know the value of potential, that is 2 volt, which is equal to I is 4 ampere, resistivity rho, length is 50 centimeter, nothing but 0.5 meter, divided by area is 1 millimeter square, nothing but 1 into 10 power minus 6. And this can be replaced as 2 into 0.5, it is going to be 1. Then resistivity is equal to 1 into 10 power minus 6 ohm meter. So this is the answer. Which option matches here? Option B is the correct answer for question number 8. Okay, let's move on to the next question number 9. The masses of the wires of copper are in the ratio 1 is to 3 is to 5, and their lengths are in the ratio 5 is to 3 is to 1. The ratio of their electrical resistance they are asking. Okay. The formula for resistance is R is equal to rho L by A. In the question they are given ratio of masses. Then so let me convert a density. Given data in the form of mass. So density is equal to mass by volume. Volume can be replaced as area of cross section into length. So that means in place of area, can I replace it with m by rho L? Yes, we can. So area is equal to m by rho L. Let me substitute it here. So then R is equal to, in place of area, why I am removing area? They didn't give any information about area. That's the reason I'm changing it. So rho L divided by, in place of area, m divided by rho times of L. So where R is equal to rho square L square by m, where R is rho is resistivity of the material, which is constant, which does not change if you change mass. Okay. So here resistance is directly proportional to length and inversely proportional to, I wrote one thing, small mistake here. So let me replace it. So here the meaning of this rho is density and this rho is resistivity. So let me change this. Here it is. So density I am going to replace it with D. So D is equal to m by area. So it's m by D into L. So it's going to be rho L by m by D into L. So it can be replaced as rho into D into L square divided by m, which is R. So R is directly proportional to L square and inversely proportional to m. This is the ratio they are given. So resistance ratio R1 is to R2 is to R3 is equal to, so ratio that they have given, L1 by M1 square. R1 is replaced as L1 square by M1. R2 is L2 square by M2 and L3 square by M3. So this is the ratio. So where the masses of the copper weights ratio, their lengths ratio they have given. Okay. So this one can be replaced as lengths. So it's going to be L1 square by M1 square is 25 divided by 1. 9 divided by 9 divided by m, and next 1 by 5. This m is 3. So finally the ratio is going to be, this is 3. So you are going to get 125 is to 15 is to 1. So this is the ratio. Which option matches? Option D is the correct answer. Okay. So let's solve the numericals based on drift velocity of electrons and origin of resistivity. Okay. So first of all, let me give you formulas of drift velocity and current. General formula for current I is equal to VDENA, where A is area of cross section, N is electron density, E is charge of the electron, Vd is drift velocity, where drift velocity can be replaced as QE by M into relaxation time, where Q into tau divided by M alone can be replaced as mobility of the electrons. Relation between mobility of the electrons and mass is inversely proportional and charge is directly proportional. So drift velocity is equal to mobility into electric field. This is the relation between drift velocity and electric field. These are the basic formulas required to answer numericals based on drift velocity and drift of electrons and the origin of resistivity. So let's get started. Question number 10. A charged particle having a drift velocity in electric field has a mobility of, they have given drift velocity and electric field and they are asking mobility. So just now I given a formula for mobility. So for 10th one solution, Vd is equal to mu into E, where mu is drift mobility. So drift velocity, the unit is a 7.5 into 10 power minus 4 meter per second. Mobility is given, it is as that's what we have to find out. No? Electric field is 3 into 10 power minus 10. So 3, 2.5 is a, send this 10 power minus 10 to left side, it will become 10 power plus 6. Then mu is equal to 2.5 into 10 power 6. So this is the mobility. So which option matches? Option B is the correct answer for question number 10. So let's solve the next question. So mean free path of electrons in a metal is 4 into 10 power minus 8. The electric field which can give on an average is 2 electron volt energy to an electron in a metal will be okay. Question they're asking is mean free path. Okay. So general formula for energy is equal to, what is the value of energy they have given? It is 2 electron volt. Voltage can be replaced as mu into E, right? Or else it can be replaced as E into L. Where is it? Here I've given one relation here. No, here is it. Where is it? Here it is. V can be replaced as E into L, where L is the mean free path that I'm going to consider. That is 2 into E into E into L. That L is replaced as mean free path. Okay. So this is energy. And right side is electric field. So what is the value of energy they have given? 2 electron volt. Okay. So from this, electric field is equal to, observe this, whatever the energy they have given, 2 electron volt, I'm just keeping it as it is. So work done in displacing the charges, force into displacement, right? The force is Q into E and displacement is mean free path. From this E will get cancelled out and E is equal to two divided by lambda. So 2 divided by 4 into 10 power minus 8, which can be replaced as 2 will get cancelled. You are going to get 0.5 into 10 power plus 8 can be replaced as 5 into 10 power 7. 5 into 10 power 7 volt per meter. So this is the answer for question number 11. Which option matches? Option C is the correct answer for question number 11. So let's solve the next question. The velocity of charge carriers of current in a metal under normal conditions of the order. Under normal conditions, the velocity of the charged particle will be in fraction of millimeter per second. It's a very small value. Next, based on limitations of Ohm's law. Okay. Question number 13. Let's solve that. The resistance of a discharge tube is. Question number 13, they're asking resistance of a discharge tube. For a resistance of a discharge tube is non-ohmic. Ohmic, non-ohmic, we have two different types. For a discharge tube, we are going to get it as a non-ohmic. Next, from the graph between I and voltage shown, identify the portion corresponding to negative resistance. Whenever current versus voltage or voltage versus current relation is given in the form of a graph, finding resistance is nothing but finding slope. For example, if I have a graph between V and I, so let me draw a straight lines because they are proportional with each other. From this, tan theta is equal to V by I, which is equal to resistance. Nothing but finding slope is nothing but finding resistance of the given value. So here, whatever the point which is having negative slope, that is going to represent negative resistance. If you observe here, point C is in negative slope, point B is in positive, point D is no slope, point E is increasing slope. So only point E is in negative slope. That's why at point C there is a possibility, that is from which region, C to D, there is a negative slope. At that position there is a possibility to get negative resistance. So for 14th question, option A is correct. Okay, next question number 15. So for question number 15 is based on color coding. So we know that yellow number is 4 and violet number is 7 and brown number is 1. So whereas gold percent is 5%, for silver 10%, and for no color 20%. Based on this, we would first two represent multiplier, that is 47, 4 into 7, and the next one represent power. It's going to be 10 power 1, right? So 15th question, which option matches? Option B. So it's going to be 10. So 10 power 0, 10 power 1, like that it is going to change, right? So plus or minus 5%. So it's going to be 470 ohms, comma 5%. Which option matches? Option D is the correct answer. If you observe next question is also of the same type. A carbon resistor of 47 plus or minus 4.7 kilo ohms, they are saying. It is in terms of kilo ohms, the 16th answer. So it means 47 kilo plus or minus 4.7. Okay, first of all let me convert this into percentage. 4.7 is how much percentage of 47? That is 4.7 divided by 4.7 kilo ohm divided by 47 kilo ohm into 100. So k kilo will get cancelled. It is going to be 470. It can be cancelled as 10%. That means, so 47k plus or minus 10% is the answer. 10% in the sense last, it is going to be definitely silver. So first two options are possibility. 4 represents yellow, right? So option B is the correct answer, which matches here. Identify the set in which all the three materials are good conductors of electricity. It's just a basic question. For 17th question, good conductors of electricity are copper, Ag and Au. So these are the good conductors of electricity. Okay, next questions, next topic is temperature dependence of resistivity. Before going into that, I would like to give one note point. So when temperature changes, resistivity and resistance of a material changes. How it is going to change? Let me give you a relation of that. That is RT is equal to R naught into 1 plus alpha T. This is the relation. Even for resistivity also, it is going to be rho naught into 1 plus alpha T, where alpha is temperature coefficient. Okay, let's solve question number 18. So in question number 18, they're saying which of the following graph represent the variation of resistivity with the temperature of the copper. Copper is a metal. For metals, alpha is positive. So as temperature increases, resistivity also increases, but not linearly. It will increases non-linearly. So like a curve, it will increases. For question number 18, which option matches? Option C is correct. Okay, so let's move on to the next. So before going to that, I would like to give some more points here. So alpha is positive for metals, alpha is negative for semiconductors, and alpha is equal to 0 for non-metals like insulators. For insulators, alpha is equal to 0. So they are completely temperature independent. Okay, let's move on to the 19th question. The solids which have negative temperature coefficient resistance are called as. Negative temperature coefficient is only semiconductors. For 19th, as I said, semiconductors only is the answer. Specific resistance of a conductor increases with. Specific resistance here it is rho T. So if temperature increases, then what happens to specific resistance of a conductor? For conductors, alpha is positive. Metals is nothing but for conductors, alpha is positive. If alpha is positive, specific resistance increases in temperature. So with respect to temperature, it will increases. For question number 20, which option matches? Option A is the correct answer. Okay. Copper and silicon cooled from 300 Kelvin to 660 Kelvin. That means temperature is increasing or decreasing? Temperature is decreasing. If temperature increases, then what happens to resistance? Resistance of metals decreases, whereas resistance of copper increases. No, sorry, it is exactly opposite. No, it is the same only. If temperature decreases, resistance of conductor decreases and resistance of semiconductors increases. Which option matches? For question number 21, option A is decreases for copper but increases for silicon. Exactly opposite. Super. Next questions are based on electrical energy and power. Okay. So next topic is energy. So let me start with question number 22. Which of the following acts as a circuit protection? Basically, it's a basic question. Fuse is the basic thing which acts as a circuit protection. Next, for question number 22, option A is correct. The charge flowing through a resistor R varies with respect to time Q is as given as AT minus BT square. They're asking total heat produced in it is. Okay. Question number 23. To answer this question, first of all, we should know what's the formula for heat produced in our formula. So for 23, formula for heat produced is I square R into T. This is applicable if I is constant. So check out here. In this question, is I is constant? How can I decide whether I is constant or variable here? Based on the charge. Is charge is constant or variable here? Charge is variable. First of all, let me calculate the current flowing through it. I is equal to dq by dt, which is equal to, so if you differentiate, we are going to get a minus 2bt. Okay, so is current is constant or variable here? Variable. So this formula is not applicable. If current is variable, the formula is integration. I square r dt is the correct formula. Then we have to substitute limits with respect to time. Initial time is t is equal to 0. The next time is time at which current is going to become 0. So if you substitute 0 here, then you are going to get t is equal to a by 2b. This is the time at which current is going to become 0. Okay, so that's what I just equated. So next t1 is equal to 0, t2 is equal to a by 2b. These are the limits of current and we know the value of current. So let me substitute this integral I square. So I square is going to be, let me expand directly, a square plus 2 square is nothing but 4b square into t square minus, it is going to be minus 4bt into a into dt. And limits are from 0 to a by 2b. So let me Expand this. A square integration is a square into t plus 4b square into t cube by 3 minus 4ab into t square by 2. So limits are from 0 to a by 2b. Let me substitute these two limits here. A square into t is a by 2b plus 4b square by 3. T is a cube by 8b cube minus 4ab. T square is a square by 4b square. So 4 will get cancelled. Then b will get cancelled. So here we go. A cube by 2b minus a cube by b. We can replace it as. So here we can cancel a b square and b square here. So finally 4 1s are 4 2s are. So finally if we common a cube divided by b, I'm left with 1 by 2 plus 1 by 3 minus 1. So which is equal to a cube by b into it can be replaced as 3 plus 1 5, 5 minus 6 minus 1 by 6. Sorry, so I just missed a point here. Just check it out. So it's going to be 3 into 2, 1 by 6. 1 by 6 minus 1 by 2 we are going to get. Because here t square by 2 is there, no? By 2. Just missed this. This is what we are going to get. So plus 1 by 2 minus 1 by 2 will get cancelled. So final answer is going to be a cube divided by 6b. In addition to this, this is I square only, into r will be there, into r. So finally we are going to get into r. Which option matches? A cube into r by 6b. Option C is the correct answer. Hope you understood. Next, let's solve question number 24. Okay, so there are two cities. Okay, so which are 150 meter apart. 150 meter apart. 150 kilometer. It's 150 kilometer. Okay, electric power is sent from one city to another city through copper wires. Okay, so the fall of potential per kilometer is 8 volt. For every 1 kilometer, 8 volt drop is occurring. Okay, and average resistance per kilometer is, okay, resistance per kilometer is 0.5 ohm per kilometer, and voltage drop per kilometer is 8 volt. 8 volt is getting dropped per kilometer. The question they are asking is the power loss in the wire. To answer this question, let me find out what is the total potential which is dropping between these cities. For every 1 kilometer 8 volt is dropping, then total voltage dropped is equal to 150 kilometer into, for each kilometer it is going to be 8 volt per kilometer. So if you multiply this, you are going to get 1200 volt. So this is the voltage. Now I need total resistance. So total resistance is equal to 150 kilometer into, per kilometer it is going to lose 0.5 ohm, which is equal to 7.5. Is it 7.5? No, it is not. 75 ohms. Okay, so this is the answer. So this is total voltage drop and resistance, and power dissipated is V square by R. V square is 1200 into 1200 divided by 75. 75 can be replaced as 25 3s are 75. 12 into 25 4s are 100. So if you multiply this, So we are going to get approximately equal to 19200 watts, which is equal to 19.2 kilowatt, 19.2 kilowatt. So this is the power dissipated. Which option matches? Option B is the correct answer. Got it? Okay. So let's move on to the next question. Question number 25. So if voltage across a bulb rated 220 volts 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which power would decreases by. Power formula is V square by R. So then delta P by delta T, or else you can write down it is as delta P by P, units and measurements concept, 2 times of delta V by V plus delta R by R. So they said only there is a change in voltage. Is there any change in resistance of the wire? No, change in resistance is equal to 0. Then delta P by P is equal to 2 times of change in voltage is 2.5, which is equal to 5%. Power is going to be changes by 5%. So here as voltage is decreasing, power also decreases by 5%. That's the answer. Option C is the correct answer for question number 25. Next question number 26. Hope you guys following all the questions and try to match with my speed. Next, let's move on to the question number 26. An electric kettle takes 4 amperes current in at 220 volt. How much time will it take to boil 1 kg of water from temperature 20 degrees Celsius? The temperature of the boiling water is 100 degrees Celsius. So here I need to give energy to change the temperature of the water. So in thermal properties of matter, we have a formula: amount of heat required to change the temperature of the substance, that is Q is equal to ms into delta T. Let me use that formula. Let me calculate the power input given to that kettle. So power input given to the kettle is V into I, where V is 220 volts and I is 4 amperes, which is equal to 880 watts. So formula for energy is equal to power into time. So which is what kind of energy that I am giving? Heat energy. So formula for heat energy is mc delta T, where is C is specific heat capacity of water, so which is equal to 4200. Okay, per kg it is 4200, per gram it is 4.2 joules per gram. So let me substitute all these values. Power is equal to 880 into time T, I don't know. M is mass, which is 10 power 3 grams, and the specific heat capacity is 4.2 joules per gram. So this gram will get cancelled. I'm left with 4.2 into change in temperature is 8. Okay, so these are the values we have, and let me substitute them. So 880 into T is equal to 4200 into 80. So 0 will get cancelled. Then T is equal to 4200 into 8 divided by 88. So this value is going to be approximately 382 seconds, which will give you approximately of 6.3 minutes of time. So which option matches? Option C is the correct answer for this question. Okay, so let's move on to the next question. Question number 27. A 5 ampere fuse can withstand a maximum power of 1 watt in the circuit. The resistance of the fuse wire is. Formula for power is I square R, which can withstand 1 watt. Current is 5 ampere, so which is 5 square. 5 square is 25 into R is equal to 1. Then R is equal to 1 by 25. 1 by 25 is 0.04 ohms. Which option? Option A is the correct answer for question number 27. Okay, next question 28. In India, electricity is supplied for domestic use at 220 volts. It is supplied at 110 volt in USA. If the resistance of 60 watt bulb for use in India is capital R, the resistance of 60 watt bulb for use in USA will be, okay, so power relation is equal to V square by R. Okay, so bulb rating is the same. Can I relate this one? V square, bulb rating doesn't change here, only voltage input that you are giving changing here. So I can write down V square is directly proportional to R. The thing I have to find out is R. Then R2 divided by R1 is equal to V2 square divided by V1 square. R2 is the second case. So what should I have to find out? So the resistance of 60 watt bulb used in USA. R2 is USA, R1 is India. That's what I am going to use. So R2 by R1 is equal to V2 is USA voltage. How much it is? 110. 110 into 110 divided by V1 Indian voltage 220 into 220. 0 0 0 0 11 1 11 2 11 1 11 2 1 by 4. So then R2 is equal to 1 by 4 times of R1. Which option matches? Option C is the correct answer for question number 28. That is the way to decide. Okay, next question number 30. So let's solve this. Sorry, before solving question number 30, let's solve question number 28. Fuse wire is a wire of, it's a basic question. Fuse wire is of high resistance and low melting point. Where it is? It is of high resistance and low melting point. Okay, next question number, that's a basic question. Okay, two bulbs of ratings, the correct relation for their resistances. Power is equal to V square by R, right? Then R is equal to V square by P. So now I have to decide which resistance is greater, which resistance is lower. Okay, let's decide based on the power rating. See, both are of having same wattage, right? Sorry, same voltage. Voltage is 200 volt for both the bulbs, right? So I can keep V as constant, then I can relate power. So resistance is inversely proportional to power. So resistance of 40 divided by resistance of 60 watt bulb is equal to power of 60 watt bulb divided by power of 40 watt, which is can be replaced as, I can write on this as 60 divided by 40, which is equal to 3 by 2. Then R40 is equal to 1.5 times of R60. So the bulb which is having low power will be having high resistance. So R40 is greater than R100. Sorry, they have given 100 watt. Okay, let it be. This one I solved for 60 watt. You can write it for 100 watt also. So R40 divided by R60, which is equal to P100 divided by P40. So which is equal to 100 divided by 40. It's going to be 2.5 times. So R40 is, this is 100, no? R40 is 2.5 times of R100. That is R40 is greater or 100 is greater? R40 is greater than R100. Question number 30, option B is the correct answer. Hope you understood here. Resistance or power are inversely related. So let's move on to the next question. A 5 degrees Celsius rise in temperature is observed in an conductor by passing a current. When the current is doubled, the rise in temperature will be approximately. We know the formula for heat generated. That is question number 31 solution. E is equal to I square R into T, where T is time, which is equal to MC into delta T in terms of temperature. From this, if you observe, let me relate current and change in temperature. Change in temperature is directly proportional to current square. When the current is doubled, the rise in temperature they are asking. Okay, so delta T2 divided by delta T1. Rise in temperature is nothing but change in temperature, which is equal to I2 square divided by I1 square. I2 is how many times of I1? It is double, no? 2 times of I1 divided by I1 whole square. I1 will get cancelled. It is going to be 4 times. So delta 2 is equal to 4 times of delta T1, which is equal to 4 into 5 degrees Celsius, which is equal to 20 degrees Celsius change in temperature. Rise in temperature will occur. Option A is the correct answer for question number 31. Let's solve question number 32. Given data is a 100 watt 200 volt bulb is connected to 160 volt supply. The power consumption would be. So question number 32 can be answered with the help of finding resistance. First of all, find out resistance. R is equal to V square by P, right? V square divided by P. V value is 200. 200 into 200 divided by 100. It will get cancelled. You are going to get 400 ohms is the resistance of that bulb. What is the input voltage given? So 160 volt. Then power dissipated is V square by R, which is equal to V square is 160 into 160 divided by 400. This zeros will get cancelled. 4 4s. Answer is going to be 64 watt. Which option? Option C is the correct answer for question number 32. Next, 1 kilowatt hour is equal to how many joules? Okay, so for 33 solution, 1 kilowatt hour, 1 kilowatt hour, which is equal to 1 kilo is equal to 10 power 3. It's 10 power 3 watt into hour. Hour is 3600 seconds. Watt second is replaced with a joule. So finally it can be replaced as 3600 into 10 power 3 watt second, which can be replaced as 36 into 10 power 5 joules. Which option matches? Option C is the correct answer. Okay. Observe question number 34. A 4 microfarad capacitor is charged to 400 volts. If its plates are joined through a resistance of 2 kilo ohm, then heat produced. So first of all, we have to understand from how this heat is going to be produced. So initially capacitor plate is charged to 400 volt. That means they'll store energy. So energy stored is 1 by 2 CV square. Let me substitute that. 1 by 2 into C value is 4 into 10 power minus 6 into 400 square. 400 into 400. So 10 power 2, 10 power 2, 10 power 4, 10 power 4 into 10 power minus 4 is 10 power minus 2. 4 4s are 16, 16 4s are 64. 64 divided by 2 is going to be 32. 32 into 10 power minus 2. So this is the value of energy stored. So this energy will be dissipated in the resistor. They are asking heat produced in the resistor. So whatever the amount of energy stored, which will dissipate in the resistor. Which option matches for question number 34? Option D is the correct answer. Got it? Next, an electric bulb is rated 60 watt, 220 volts. The resistance of this filament. Okay. Question number 35. They're asking resistance of the filament, right? So our resistance R is equal to V square by P, where V is 220 into 220 divided by P. P is 60. So 0 0 will get cancelled. 22 into 22 is 484. 4840 divided by 6, which is approximately 807 ohms is the correct answer. So which option matches here? Option D is the correct answer. Let's finish question number 36 also. In question number 36, a current of 2 ampere passing through a conductor produces 80 joules of heat in 10 seconds. The resistance of the conductor. They are asking heat. Heat is a form of energy. So which is power into time. Power is I square R into T. Heat produced is 80 joules. Let me replace all these things. Heat is 80 joules, which is equal to I value is 2 square 4 R into 10. This will get cancelled. Then R is equal to 2 ohms is the correct answer. Which option matches? Option B is the correct answer for question number 36. Okay, very good. So let's move on to the questions based on combination of resistors, series and parallel combinations. Okay,